So we've talked a lot about finding factors and getting all of those little bubbles that you can take. Now, the whole purpose of doing that is to figure out your rational zeros. See, what's going on is you have your xy axis and you have your polynomial that goes through here somehow. Okay, and you're trying to figure out what are these points where it crosses the x-axis. These are called our zeros. This is where whatever x you plug in, you get y equals 0. And so when we take our bubbles, and I know that x plus 6 equals 0, when I take that bubble and I set it equal to 0 and I get x equals negative 6, that's telling me that it's crossing there at negative 6. That's one of the places that's crossing. So that's what you're trying to do. You're trying to find all of those spots. Now sometimes you're not going to have something that you can bubble, so you can't do this kind of thing with it. Sometimes you're going to have to do that some other way. And so what we do is we develop this theorem that helps us find them easily, especially using synthetic division. Because remember, when we use synthetic division, if we can get it the remainder to be 0, then we know that it's a 0. And so the rational zeros theorem tells us the rational zeros. Now, example of rational numbers, they're fractions. So maybe my 0 is going to be 1/2. It's going to cross there, or it's going to be 3/2. But maybe also it's a whole number, like 0, 1, 5, negative 2. Okay, so it could be any of these. The thing it's not going to find, it's not going to find a square root for you. It's not going to find an I for you. It's not going to find a combination of I square root of 2 or 2I. It's not going to find any of these. None of these are going to be found using the rational zeros theorem. The only thing you're going to find are your whole numbers, your negative numbers, and your fractions or decimals. That's all you're going to be able to find with it. But hopefully once you find those, and if there are any of these guys, then you'll be able to find that using the quadratic formula. So here's what the rational zeros theorem is, and you should write this down in your notes. This is really important. So possible rational zeros are going to be found by making this fraction. In this fraction, on the very top are going to be the factors of the constant. That's this number right here is your constant number, the number without the x. And on the bottom is going to be the factors of your leading coefficient. That's the number in front of your biggest exponent. So in this case, it would be a 1. So that might seem a little bit weird, so let me show you what I'm talking about. So here's my polynomial. I want to see what are all your possible zeros. Now, by the way, before I show you that, let's just focus in on this. See, right now, I have no idea what could work. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Maybe the negative of those, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, all kinds of stuff. What about the decimals? I didn't even do decimals in there. What could I have? I could 1 1.5, 1 1/3, 1 1/4, 1 1/5, 1 2/5, 1 3/5, 1 4/5. And so I'm kind of exaggerating a little bit, not exaggerating, but I'm just trying to make an emphasis here that there's all kinds of zeros that could be possibilities. So what's really nice about what we're about to do is it's going to narrow it down. Instead of being an infinite number of possible zeros, because we could think of any number in the whole world except for square roots and I, we could think of any number and try that. Instead of having an infinite number of zeros, we're going to narrow it down to like 5, 10, 15 of them. And although 15 might seem like a lot, it's actually a lot less than 1,000 or 2,000 or 1,000,000. So it's really nice to be able to narrow it down. So let's just try it out. So what I'm going to do is on the top of this fraction, I'm going to look at the negative 12. And I'm not as worried about the negative as I am just about the 12. So what numbers go into 12? We have 1, 2, 3, 4, 6, and 12. But the other thing is we're doing all factors of 12. So I also want to include the negative of all these numbers. So it's really plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. All right. On the bottom, notice the biggest coefficient here, or the biggest exponent, the coefficient is nothing, so we put a 1 there. So that means on the bottom is just plus or minus 1. And how that works is I can look at 1 over 1, negative 1 over 1, 1 over negative 1, negative 1 over negative 1. Basically, any combination of that just gives me plus or minus 1. Okay? Then I go to the 2 over 1, 2 over negative 1, and so on. So basically, all of these are just going to stay the same. Sometimes what happens is you'll get a 2 on the bottom. And so then what would happen if we had a 2 on the bottom is I would have to look at 1 over 2, 2 over 2, 3 over 2, 4 over 2, and so on, and include all those. So I have 2, 4, 6, 8, 10, 12 different possible zeros. It seems like a lot, but it's not bad. So now what we're going to do is we're going to try them out. We're going to see which one of these works. So what we do is we use synthetic division. If we get a 0 at the end, then it works. If we don't get a 0, then it's not a 0. So let's just start out. I'm going to start with 1. Sometimes it works, sometimes it doesn't. Remember synthetic division, I put a 1, 2, negative 11, negative 12. Okay, I drop my 1. 1 times 1 is 1. Get a 3, that would be 3. This would be negative 8. 1 times negative 8 is negative 8. This would be negative 20. I did not get 0 here, so 1 is not a 0. Okay, maybe I want to try negative 1. So I put negative 1 in a box. I go back to the 1, 2, negative 11, and negative 12. Okay, so I drop the 1, I get negative 1. Negative 1. That gives me negative 12. Negative 1 times negative 12 is a positive 12. And look, I got 0. So, wow, that's gonna, okay, negative 1 works. That's awesome, negative 1 works. Here's the thing. I have to find 2 more zeros because whatever your exponent, your biggest exponent is, that's how many zeros you should get. You should get 3 zeros. I only have 1 of them so far. So now I have to work at getting 2 more. Now here's the thing. We could keep doing what we're doing. So we could get 2 and we could put it in a box. We could put down 1, 2, negative 11, negative 12, put those down here and work it out. The problem is if I do that, I am going to then still have back down to a quadratic. Here's what I mean. When we just did this, remember before what we would do is we would say, well, that means that if I divide by x plus 1, and I got that because I had a negative 1 here, remember when you put it in the bubble, you change the sign, then my answer that I got was x squared plus x minus 12. That's my answer I got. And so what's happening is I already know my 0 for this one right here. Now what I want to do is I want to take and I want to find what are the zeros here. So what I'm going to do is I'm going to take this answer I have and I'm going to keep doing synthetic division until I get that down. Or your other possibility is this is a quadratic. We could double bubble or we could complete the square. And typically we double bubble, meaning I still have x plus 1, but now I'm going to have x and I'm going to have another x. And let's see, oh, this is a box problem, isn't it? So we make the box. We've got x squared. We've got minus 12. We've got x and x. 3 and 4 are going to be my numbers. So I get 4x and 3x. I have a positive x that I want to get, so it'll have to be a negative 3. So my other bubbles are x plus 4 and x minus 3. So that means my zeros are as follows. I get the negative 1 from here. I get the negative 4 from here. And I get a positive 3 from there. The other way you can find that is set them equal to 0. X minus 1, or x plus 1 equals 0 and solve. X equals negative 1. X plus 4 equals 0 and solve. X equals negative 4. X minus 3 equals 0 and solve. X equals 3. Either way, you can either look at it as taking the opposite of each of these numbers, or you can look at solving it, setting it with a 0. But here are my 3 zeros, and those are the only 3. By the way, let's go back up here and talk. You see how up here in my possible zeros there is no 5? That means 5 is not a possibility. It is not. There is no way 5 is going to work. Neither is 7, 8, 9, 10, 11. None of those are going to work. So you're not going to try them. You're only going to try the numbers here. So again, what we do is we start with one of these numbers up here. If it doesn't work, go to another one. If it doesn't work, go to another one. Keep on doing that until you do get something that works. And then what's going to happen is you're going to be left with a quadratic probably, if it was an x cubed problem to start with, and then you can double bubble it. Or you can take your answer and keep doing synthetic division, just picking another number from your grouping. All right, let's look at another example. So here we go. I'm going to find my possible zeros. So I make a fraction. On the top are going to be multiples of 30. So 1, 2, 3, 5, 6, 10, 15, and 30. On the bottom, I'm looking at 1 again, so it's just plus or minus 1, which is nice. And so now I'm going to try synthetic division. And so sometimes you want to just start with 1 and go for it. I might just start with 3 just for something different. So I've got 1, negative 4, negative 11, and 30. Drop the 1 down, multiply by 3, I get negative 1. That would give me negative 3. This is negative 14. This is negative something big, and I don't care because I know it's not negative 30, and so it's not going to be that. Okay, so 3 does not work. Let's go down to 2. Let's just try 2. So 1, negative 4, negative 11, and 30. Drop the 1, get negative 2, negative 4. This is negative 15. 2 times negative 15 is negative 30. Ooh, that worked. Okay, so now what does this mean? This means that x minus 2 times my answer, x squared, minus 2x minus 15, okay, multiplies to give me back that polynomial. And so now, can I figure out the rest of these using a box? Or I could take this right here, 1, negative 2, and negative 15, and I could start trying another number. Maybe I want to try negative 2. So I drop down the 1, I get negative 2 times 1 is negative 2. That gives me negative 4. Negative 2 times negative 4 is a positive 8. That didn't work. So maybe I want to try something else, like negative 3. I haven't tried, see, I tried positive 3, but I haven't tried negative 3. Maybe that'll work. So let's try that. I drop the 1. Negative 3 times 1 is negative 3. Negative 2 minus 3 is negative 5. Negative 3 times negative 5 is a positive 15. Ooh, that worked. That gave me a 0 there. Okay, so now I know negative 3 is 1. So I know 2 is 1 and negative 3. So I have one more. Well, I can find that because this is x minus 5. And I can take x minus 5 and set it equal to 0. So then x equals a positive 5. There's my third one. So you have all kinds of ways. I could have taken this and put it in the box and double bubbled, and I would have gotten x plus 3 and x minus 5. Okay, so there's all kinds of ways of doing this. You just need to find your zeros. Do what you feel comfortable with. So here's another one. So I find my possible zeros. On top, I'm going to take the multiples of 9, 1, 3, and 9. On bottom, will just be multiples of 1. So now I have fewer to try here. I only have 6 to try. So let's just try 1 and see if it works. So we got 1, negative 9, and 9. Drop that down. 1 times 1 is 1. Got 0, 0, negative 9, 0. It worked. All right. So now I have x minus 1 times x squared. There is no x because of that 0 there, minus 9. And I hope you see that this x squared minus 9 is a special double bubble problem, x plus 3x minus 3. And so what are my zeros? My zeros are, if all of these equal 0, I'm going to get x equals 1, negative 3, and a positive 3. And those are my 3 zeros. All right. I don't think we have that much more. Let's check it out. Nope, it's just one more example. And then it's going to be you trying this in class, but make sure tomorrow that you ask questions if you do have any, because this is pretty difficult. We'll spend some time on this actually. So I'm going to look at the possible zeros. I've got 1, 2, 3, and 6. And on the bottom is going to be plus or minus 1. So I'm going to try this out using synthetic division. I'll just try 1 to start with. 1, negative 7, 10, and 6. Drop the 1. 1 times 1 is 1. Get negative 6. 1 times negative 6 is negative 6. You get a positive 4. 1 times 4 is 4. That doesn't work. So then maybe I'll try a negative 1. Drop the 1. I get negative 1. That gives me negative 8. That gives me a positive 8. That's 18. It's definitely not going to work. Alright, so then let's try 2. We get 1, negative 7, 10, and 6. So we get 1, 2 times 1 is 2, get negative 5. 2 times negative 5 is negative 10, you get 0. Okay, that didn't work. Maybe we'll try negative 2. So sometimes it's going to take more than just 1 or 2 tries. We get negative 2, that gives me negative 9. That would be a positive 18, that's way too huge. Alright, let me erase some of this. Now we got to go on to the 3's. So we get 1, negative 7, 10, and 6. Negative 4, that's negative 12. I get negative 2, gives me negative, oh, there it is. Okay. So now I've got x minus 3 times x squared minus 4x minus 2. Oh boy, this was interesting because here's the thing. If I tried to box this, I'm not going to be able to. This is not a boxable or a double bubble problem. So what I'm going to have to do is I'm going to have to do the quadratic formula for this. Okay, so this is where it's where this doesn't work. Quadratic formula is where it's going to get the ones that don't show up there. So we're going to use the quadratic formula. x equals negative b, b is negative 4 here, plus or minus the square root of b squared, minus 4 times a is 1, c is negative 2, all over 2 times a is 1. So then we get positive 4 plus or minus square root of 16 plus 8 over 2 gives me 4 plus or minus square root of 24 over 2. Okay, well 24 is, let's see here, 12 times 2 doesn't help. 4 times 6 is going to be the one. So we have 4 plus or minus square root of 4 is 2. I'm left with the square root of 6 all over 2. And then notice that I have a 2 I can take out of all of them, so I should. So then I get 2 plus or minus square root of 6. Okay, that's two answers, right? That's 2 plus the square root of 6, and that's 2 minus the square root of 6. So there's two answers, and then we found that x equals 3 is another answer, so there's our three answers, our 3 zeros for this.